Hassler here. I'm going to work through lesson 7.4. We are going to continue to look at parabolas, the graphs of a quadratic function. And our big focus is going to be on the axis of symmetry today. And so in problem 1, it says the graph of a quadratic function, y equals f of x, is shown. Use this for problems 1 through 3. So the first thing we're going to do is identify the axis of symmetry. And if you recall, the axis of symmetry is this vertical line that cuts right through the vertex, okay? And we're cutting through the x-axis. It's an x value, so we write x equals. And I'm cutting through the x-axis at -3. And so my axis of symmetry is x equals -3. It says identify the x-intercepts. And again, if you recall, the x-intercepts are where I cross the x-axis. And so I cross the x-axis right here at -5. So I'm going to write that as an ordered pair, -5, 0. And again at -1. And so I've got -1, 0. You could also write this as x equals -5, -1, but we do not want to put parentheses around the -5 and -1, or else that looks like an ordered pair, and -5, -1 is not the ordered pair of an x-intercept. C says, what's the relationship between the location of the x-intercepts and the axis of symmetry? And so what I notice is that my x-intercepts are 2 away from that axis of symmetry on either side. So we can say both are 2 units away from the axis of symmetry. Or we could say that they are the same distance away from the axis of symmetry on opposite sides. So I'm going to write on opposite sides. Sorry about that. Here we go. Okay, and this is actually going to be the recurring theme as we move throughout this lesson. Axis of symmetry and how far away points are on either side of that axis of symmetry. All right, let's look at question 2. Question 2 says, find the y-intercept of the graph. And so my y-intercept is going to be where I cross that y-axis, and so that is at 0, 5. Find another value of x with the same output as the y-intercept. Okay, so the output of the y-intercept is 5. And so if I look across my graph here, I have another point with an output of 5, and that has an x value of -6. So an x value of -6, really I have that ordered pair -6, 5, where the output of the y-intercept is the same as the output at this value. So it shows the value on the graph. All right, did that. What's the relationship between these x values and the axis of symmetry? So let me actually put that axis of symmetry in there a little bit better. And again, it looks like I'm 1, 2, 3 away from the axis of symmetry, and 1, 2, 3. So again, we are the same distance away from that axis of symmetry. Okay. Question 3 says, if f of 4 equals 45, which other x value gives an output of 45? All right, well, let's see. I don't even have 4 on my graph, right? F of 4, that means that 4 is an x value. So if I have an x value of 4 and the output's 45, there should be a point on the other side of my axis of symmetry that's going to match that. Well, 4 would be somewhere over here, which means that somewhere over on this side would be an x value that has the same output, right? That's the whole idea. Up here in question 2, we said, hey, there's a point on either side of the axis of symmetry that has the same output, 5. And technically for the x-intercepts, there's a point on both sides of the axis of symmetry that have the same output, 0. And so because a parabola has this symmetry, if I have an x value of 4 and that output's 45, there's some x value on the other side of the axis of symmetry that has that same output. And again, from questions 1 and 2, we notice that these should be the same distance away from that axis of symmetry. So really, what I need to figure out is how far away is -3 from 4? So -3 from 4, that would be what, 7 units away 4 is 7 units away from -3. So that means that I need to be 7 units away, but on the other side. I really need to take 7 units away. So I really have -3, that's my axis of symmetry. And because I'm moving to the left, I'm on the left side of that axis of symmetry, I'm going to take 7 units away. That's really my distance. And if I do that, I get -10. And so f of -10 would be equal to 45 as well. Okay? All right, so these are the main ideas that we are working with, and we are going to use these ideas to help us answer question 4. Different graph for question 4. So question 4 says, a parabola has a vertex at 2, 5 and passes through the point 5, -4. So I have a graph. I have both those points plotted for you. It says, does this parabola open up or down, and how do you know? Well, if my vertex is at 2, 5, then in order to get to the other point, my parabola is going to have to open down, okay? And so it's going to open down. I'm going to say because 5, -4 is below the vertex. It wouldn't make any sense for my parabola to open up if the vertex is above the other points. All right, B says give one other point you know for sure is on the parabola. Well, hey, I'm going to go ahead and draw in that axis of symmetry because up above we said that I have points the same distance away from the axis of symmetry on both sides of that axis of symmetry. And so the key through this lesson from here on out is to draw in that axis of symmetry. When I draw in that axis of symmetry, I notice that I have this 0.5, -4, and it is 1, 2, 3 units away from that axis of symmetry. So if I have to give one other point that I know for sure, 100% certainty, is on this parabola, I know for sure on the other side of that axis of symmetry, 1, 2, 3 units away, I'm going to have another point. And that point's going to be -1, -4. Okay, same y value, same output as that other given point. In fact, I can use that point to finish drawing the rest of my parabola. Okay? All right, C says the parabola has an x-intercept of 4.236. Find the other x-intercepts. All right. Well, let's see. 4.236. Oh, yeah, I did a pretty decent job there of drawing that in, 4.236. So how far away is my axis of symmetry to 4.236? Now, my graph is kind of getting a little muddled, so I actually am going to draw a number line. I think a number line is a super great strategy to kind of make things a little clearer. And on that number line, I'm going to put that axis of symmetry is at x equals 2. And I'm going to drop my x-intercept, which is at 4.236. And so now it's a little easier for me to say, hey, if I add 2.236 to that axis of symmetry, I would get 4.236. These are 2.236 units apart from each other. And so what I need to do is on the other side, I need to take away 2.236. And so I'm going to do 2, that's my axis of symmetry. I'm going to subtract that distance, 2.236. And when I do that, I get -0.236. Okay, and so again, I'm using this number line to help me identify what the other point would be with that same distance away. And I'm using this axis of symmetry. It's cutting down through the middle of these points. So let's go ahead and take some notes, some quick notes. And a couple ideas that I want to include for these quick notes is the fact that parabolas are symmetric across that axis of symmetry. Not a new idea, but an idea that is fundamental in understanding how to answer these questions. So we can say parabolas are symmetric across the axis of symmetry. Okay, and so here's what that really means. 1, that means that the axis of symmetry is halfway between any point, any set of points. I'm specifically going to mention the x-intercepts here, though. So we can say the axis of symmetry is halfway between the x-intercepts. Now I'm leaving space intentionally to draw a picture. So if you're wondering why I didn't extend my sentence there, we're going to end up drawing a picture here. Let's go ahead and do that. And so if I just draw a parabola, doesn't matter how you draw it, where you draw it, okay? What we're saying is that if I know what the axis of symmetry is, then my x-intercepts, where I cross that x-axis, that axis of symmetry is cutting that distance in half, okay? I have the same distance on either side. In fact, the other thing I want to say is that points equidistant, same distance away from, so points that are equidistant to that axis of symmetry have the same y value. Okay, and that's what we were talking about back here in these lessons up at the top, right? We were saying that, hey, in problem 2, these both have an output of 5. In problem 1, these both have an output of 0. And so in problem 3, I'm looking for another x value that has the same output of 45. I'm looking for x's that are the same distance away from the axis of symmetry, and those are going to have the same output values. Okay? All right. And so your job is to attempt the check your understanding. The key will be posted for you to look at after you give that attempt. And then 7.4 practice. And if you have questions, let me know.